Okay, so let us make a start on fitness tests. And I guess I've got a couple of intentions with these fitness tests. I want to describe them to you. I want to describe the protocol or the way of setting them up to you so you understand that. But beyond that, I also want to sort of really clearly address the ideas of validity, of reliability, and practicality. So I guess what that means is practicality. I guess what that means is I'm going to provide some kind of evaluation for each of these in this, at least this first recording, these aerobic tests. Now, look, I've chosen aerobic tests not because we kind of have to separate them up this way. It's just I find it practical to think about them in these groupings. Feel free to mix them up in your own mind and go through them in alphabetical order, all different aerobic, anaerobic ones, whatever works for you. But for me, I think it's useful to do it this way. So on that basis, let's make a start. We have one over here, which I'm pretty confident a lot of you are going to know and, of course, love. And that is what we would call the MSF, the multi-stage fitness test. Okay? The multi-stage fitness test. And the only thing I'd say in there, we've got another acronym where you might want to know, is it was originally developed by the NCF, the National Coaching Foundation. So it's called the NCF MSF test, the multi-stage fitness test. You probably refer to it as the bleep test, but try and build this language in if you're able to. So what does it actually do? Well, first of all, it is a prediction of VO2 max. Okay, it's a prediction of the maximum volume of oxygen that a performer can utilize within each minute. Okay, so we've got a prediction. Now, you might want to think about the word prediction and think about whether that creates any strengths and weaknesses, evaluative skill, with regard to this test. But it's a prediction of VO2 max. Secondly, I'm also going to refer to it as what we call a field test. Now, field test means that a couple of things really. One is it's not conducted in a laboratory, but in fact it's conducted with large groups of people in sort of non-specialized areas. And we've got a classic example of that here with these performers here. I'm not sure if they're basketballers or Aussie rules footballers. I'm not sure what they're doing. But it's a field test. It's produced, it's developed, and it's done in the field in places like schools or clubs. And it's done with large numbers of people all at the same time. Another point I'd like to kind of get to with you here, it's also a maximal test. Now, maximal tests are very interesting because they require the performer to go to exhaustion. Again, can you start to evaluate that sort of concept? And we're going to do exactly that in a few moments' time. Now, in terms of the protocol, a couple of things you probably already know, but we are talking about 20-meter shuttles. Okay, so these performers here are going to cover 20 meters during each of their individual shuttles. And the other thing I would sort of add here in terms of protocol is that each level is 1 minute. So we've got 1 minute levels. Okay, so each level is 1 minute. Now, what does that mean in practical terms? It means, of course, on level 1, when we take the first shuttles at the slower speed, we've actually got fewer shuttles in the 1 minute level for level 1 compared to, I don't know, level 16, which is pretty elevated, where the shuttles are much more rapid. So you're going to have far more shuttles within that 1 minute period. So, of course, that increasing velocity of the running is important here. Now, let's get on to what we'd consider advantages. So I'm going to do advantages up here in green. Okay, so I'm just going to call them A's. A's, okay, that's an S, believe it or not. A's, advantages. So for me, the key advantages to this test are it's cheap. Okay, so it's perfect to be done with things such as large numbers of people. So in a sports club type environment, it's going to be much more effective and much more practical, remember practicality over here, compared to something more laboratory based. But we also have to look at the disadvantages. So let's put them in here. I don't think I've got the right red, but never mind. Disadvantages, what would we consider those to be? Well, for us, disadvantages are going to be things, are going to be things such as that this really, one of the things it measures is running technique. Now, what if we are interested in measuring, or predicting is a better way of putting it, predicting the VO2 max of, say, a swimmer or a cyclist? Will this running and turning technique limit the validity? Validity is measuring what it claims to measure. Will it limit the validity of the test? So the fact it is running technique based. The other point is we've got issues of motivation here. Why? Because as we said before, it's a maximal test. We're going to revisit this point a great deal. And finally, it's a prediction only. Prediction I haven't really left myself enough space. It's a prediction only. So this is not a direct measure of aerobic capacity of VO2 max, something we're going to come back to in a moment. So we've got a very practical test. We've got a very well utilized test. We've got a a test which is very, almost everybody does it, I think, at some point in their life, which is really a phenomenal thing, actually. I've never thought about that before. But nevertheless, it is limited for the reasons that we've got here, or the reasons we've got here, let me say. Okay, so let's move on. The next test I want you to have a look at is what we call the 12-minute Cooper run. And again, I would predict that probably a lot of you have had a go at this. So how does it work, this 12-minute Cooper run? Well, it works like this. Again, it is what we call a field test. It is done in the field, literally sometimes. I'm not saying we're not saying with field tests it's done in a field. This one's not cleared in a sports hall. But field test means it's done in the field. It's done in the practical setting. So this is also a field test. Secondly, what we're going to say here, of course, is the test lasts for specifically and exactly 12 minutes. So unlike the multi-stage fitness test where we don't know at the start how long it's going to take somebody, this is specifically a 12-minute test. And athletes are, again, encouraged to either run, but they can also walk. Now, the walking comes into play not because someone doesn't feel like running that day, but because we might be doing this test, say, with someone recovering from an injury or recently recovered, or someone of a more mature age might also take part in this test. And what do we measure? Well, the key thing that we measure, we measure in that 12 minutes, what distance does the athlete or the participant cover? So it's distance covered is the figure that we produce as a result of this. Now, advantages. Let's cover our points about advantages. We put them up here again. Advantages, A's. Advantages, again, we've got very good practicality here. It's cheap. In fact, it can be as cheap as free. And it's simple to conduct. Okay, so those are clear advantages for taking part in this sort of activity in a club type scenario. But we have disadvantages. Let me put them up here. I think I've chosen a different red this time. Disadvantages. And the disadvantages we've got here, again, we've got the notion that this is running based. It's a technical performance running. So therefore, does that limit the participation of certain performers? Again, we've got the limitation of motivation. This is effectively a maximal test. And finally, we are going to compare the results to kind of like population level results. Well, what if one group runs on a track and another group runs on sort of a pitted field, for example, or wet grass? Does that change the validity of the results? So we've got some of those. So we've got some of those considerations as well. So let me just drag you down. We've got a couple of other tests that we're looking at here. So the one over here really contradicts what we've just talked about, and I'm going to refer to this as what we call direct gas analysis. You'll often see these referred to as a ramp test, direct gas analysis. I'm just going to turn the gain down on my microphone, folks. So I'm going to have to speak a little bit louder, but I have quite a lot of noise around me outside. So I'm going to try and get really close so that you don't hear too much background noise and you hear me much better. So direct gas analysis, how are we going to describe this? Well, unlike what we've talked about so far, this is a lab test. Lab meaning, of course, laboratory. A lab test. We conduct this test in a lab. We clearly see, therefore, that we've got differences. One of the categoric differences is, of course, now we are not predicting something, but this is a direct measurement. Okay, and that's really important because it's going to be a very, very specific and accurate outcome. So what is it that we're measuring? Let's have a look here. We're measuring, we're measuring oxygen in minus oxygen out. Okay, so we're going to get some figure if we take the oxygen that this person breathes in and we deduct from that the oxygen that they breathe out, and we measure that specifically. Of course, what are we going to end up with? We're going to end up with a measure of oxygen utilization. Okay, so we're going to have a measure of O2 utilization. So how much oxygen has the performer been able to take in to not just into their lungs, but down and actually into their system, which is ultimately going to be utilized, and hasn't breathed that oxygen back out. And one of the interesting things you might want to know is when you guys breathe out during exercise, the air that you breathe out is approximately 16% O2. approximately, varies from person to person and fitness levels. But that approximation is important because, of course, we don't take all of the oxygen out of the air that we breathe in, just some of it. So therefore, we can measure it in this way, and it changes if we become fitter. More of which in other videos. Now then, let's also just note that we'll often refer to this as what we call a ramp test. A ramp test. And a ramp test, what that means is that, as you see here, this person's on a treadmill. And what we tend to find with ramp tests is that the intensity of the work is increased until the exhaustion point. And of course, at that exhaustion point, you can specifically measure the quantity of oxygen which is being consumed just prior to exhaustion, getting that maximal reading, that VO2 max. Okay, advantages, some clear A's for us here that we can evaluate. Well, first of all, it's a measure. It's therefore specific. It's therefore valid. It's therefore reliable. The other thing is the environment is what we call controllable. You are in a laboratory scientific condition and you can minimize the variables. And finally, this can be done in a sport-specific way. So you might be thinking, well, a treadmill is still running. But yes, you can do this on an ergometer or a bike. You can even have effectively a water treadmill for swimmers, for example. I'll encourage you to Google that particular image. But in other words, because you're in the laboratory condition, you can make it specific to the performer. Now, there are disadvantages, so let's honour those and address those, and you can probably figure out what they are. But the first thing we say is that we've got one performer only, so only one performer at a time. That's an important point. Secondly, we can say disadvantage is expense. This is an expensive thing. And finally, we can say that it requires a lot of equipment, not least the treadmill, the computer, the Douglas bags, the gas analyzers. It's an expensive thing. All right, let's move on. What do we have over here? Well, we've got two more to go here. And here we have what we call a yo-yo test. Now, there are various models of this, so be encouraged to read beyond what I tell you here. The first thing I want you guys to grab hold of is that this is what we call an intermittent test. Now, of course, if it's intermittent, there's a T on the end of there, by the way. If it's intermittent, that means that the performer performs and rests in between those performances. And where it becomes aerobic is, it's what we'd call based on recovery. Okay, I'll explain this to you. Based on recovery. So what we mean by that is, you see here, in this area here, we have effectively a recovery zone after the yo-yo sprints. We've got a recovery, and the thing that this test is really measuring is how rapidly can the performer recover in that zone. And it's a very short recovery, and of course recovery itself is aerobic. So in that sense, it's testing the aerobic capacity to recover, and I think that's a very, very interesting process. In fact, let me actually note that down. So we're talking about the aerobic process to, amongst other things, to remove lactic acid, or in other words, to recover the lactic acid anaerobic energy system. And there's a bit of creatine phosphate recovery in there as well. So let's have a look at how this works. You see here, the performer is going to sprint from here to, in fact, it's going to be from here to here and then back again. Okay, so what's that? That's 20 meters, 40 meters in total with a turn. It's going to take them in the region of 9 seconds to 10 seconds. And then when they get back, they're in this recovery zone for 10 seconds. And that is going to be repeated. That methodology is going to be repeated. And of course, what we're going to do there is we're going to take the times that it takes to cover these distances, and therefore we can get effectively a reduction in performance over time. Now, advantages, which this time I'm going to pop down here. Advantages. My handwriting is very poor today, never mind. First of all, again, we've got these practicality points. It's simple. It's cheap, even free. A bit of cones is pretty much all you need. And we've got large numbers again. So these are all advantages. But again, we have to honour our disadvantages. Let's put our D's up here, our disadvantages up here. This is a maximal test. Therefore, we could have issues of motivation. Now, again, we could talk about the issues of running here, but I think they're less relevant in this one because the thing that's ultimately being measured is the static recovery period. All right, one more test to go. Let's have a little look at it here. This one here, and this last one, and then you can switch me off. What we've got here is we've got here one example of a step test, and this one is the Queen's College step test, the Queen's College step test. Okay, so there's numerous step tests. I'd really encourage you to look at different ones. So the first thing I'd like you to be aware of with this one is it involves what we call a metronome. A metronome is a pulsed, regular, specific timer. You've got an image of it here. Interval, a bit like the bleeps of a bleep test or an abdominal conditioning test, and it sets exactly the pace that the performer has to step onto the step. Secondly, the performer in the Queen's College version, they're going to perform their steps on the metronome for 3 minutes. Okay, for 3 minutes. Every person is going to perform for 3 minutes. I should say, by the way, that the metronome would be set for 24 steps for men or 22 steps for women. Okay, so we have a male and female version of this test. Next point I'd make is that what we're going to do is after that 3 minutes is up, we're going to measure heart rate immediately after the performance ends. And based on that heart rate, what we're able to do, and I'd really encourage you to have a go at this, what we're able to do based on the heart rate that we have immediately after 3 minutes of exercise is that we're able to estimate VO2 max. And I want to introduce a concept to you which you're going to need a little bit later on. VO2 max is a relative value because it's based on milliliters per kilogram per minute. Now let's have a think about that. The minute bit is the same for everybody. However many milliliters is going to change from person to person. That's going to effectively say how aerobically fit different people are. The higher the value, the higher your VO2 max. But of course, it's relative because it depends on how heavy you are. So it's not the total amount of oxygen taken in, it's the total amount of oxygen taken in divided by how heavy a person is. And of course, generally speaking, bigger people are going to have bigger aerobic capacity because they need that power to be able to propel their mass. But of course, we might find differences in that. And I think it's an interesting thing just to dwell on. Now, advantages, which I'm going to put over here. We're going to say that this test is submaximal, which is a clear advantage over the others because motivation becomes less of an issue. It's simple and practical again, and it's cheap. And we've said that numerous times already. But disadvantages is this is a prediction, not a measure. It's a prediction, not a measure. So we benefit from the submaximality, made that word up, don't even know if it exists. But on the downside, therefore, the test is by definition then a prediction, not a measure. So a lot of information there. I encourage all of you to participate and engage with these protocols and tests, and I hope this video has been useful.